Welcome to this Java Break with Basis. The topic for our session today is Triggers Facilitate Easy Upgrades. During this session we'll show you how we put triggers to work in your Pro5 and BBJ applications to facilitate easy upgrades to those applications. My name is Nico Spence. I'm the CEO of Basis International, and I'll be joined today by Nick Decker, our engineering supervisor, who's going to help me through some demonstrations of triggers in action. Let's have a look at our agenda. The first topic is, what are triggers? We'll talk a little bit about how triggers are structured, how you can create triggers, and what their functionality is. Then we'll look at the use cases for upgrades utilizing triggers. We'll look at SOX Compliancy. We'll talk about how we can control access to the data. We'll talk about encrypting data. And then lastly, we'll talk about auditing, being able to create audit trails, log in who's had access to your data. Show you how you might be able to utilize triggers to facilitate the creation of a data warehouse in a far more efficient style than might have been employed in the past. And then we'll look at integration of new modules. We'll look at a particular use case here within Basis where we've integrated a new module with some of our older application software, and we've utilized triggers to make that seamless. And then we'll take your questions. So let's get started. So what are triggers? Triggers really are simple BBJ programs. They automatically execute in response to access to a data file. That allows you to manage and control access to and manipulation of the data in those data files. They're implemented at the file system level, and they execute regardless of the file access method used. So be it a read record, or read with an IO list, SQL select statement, or even using Basis's record set structures, triggers will fire. So let's have a look at the components of triggers. Firstly, there are three read and write remove trigger types. So we have read, write, and remove. So read record, write record, etc. And we also have triggers that can fire on the opening of a data file, on the closing of a data file, or on erasing a data file. And there are three execute options that come with each trigger type. We have a before execute option, so we can interrupt the process before the actual execution, for example, of a read or of the open of a table. We have after execution options, and we have instead of execution options. So we can replace the code that would have been executed within the application on the right and replace it with a different write, for example. So triggers are file-based. They do not require any SQL syntax, does not require a data dictionary. So any BBJ or Pro5 type business logic that you may have can be embedded within a trigger. So because it's business basic, because it's BBJ, you can have Java logic, you can have read record, write record logic, you can have SQL logic. The triggers can be enabled and managed via the Enterprise Manager, or you can do it via SQL. So you can use SQL syntax to deploy a trigger at a client site. Debugging is now also available to triggers. It's available on the system console. Wherever the file system may be installed, you can enable debugging. And that is a flag that you can set within the Enterprise Manager. Triggers are interpreters that are cached for optimal performance. So the overhead required to fire a second invocation of a trigger is very, very low. So you should see some performance advantages in the later releases of BBJ. And you can utilize triggers, therefore, with Pro5 and Visual Pro5 when you're accessing the data files through the Basis database management system. In other words, when it's under the control of BBJ, triggers can fire. So you can very easily integrate a trigger into an existing system. The application code itself doesn't have to be aware and does not need to be aware that a trigger is in place. No file conversion is normally necessary. No additional licenses are required. No code changes are required for the applications, and I'll show you some examples of that when I hand over to Nick. So this makes it really perfect for easy functional upgrades to your application. Very little risk to your application as long as you've tested your trigger functionality you can be comfortable that the application won't be affected because this all takes place at the database level, at the file system level. So let's look at some use cases for triggers. I mentioned earlier the Sarbanes-Oxley Compliancy, the compliancy for companies to take care of their customers' data and make sure that that information is securely held. If, for example, it's customers' credit card information or social security information, that information needs to be securely held on disk. Now, you may have written an application many years ago when Sarbanes-Oxley Compliancy was not a requirement. How do you go back and retrofit that application? It could be an enormous task measured in multiple man-years. Well, the good news, with triggers you can control access to the data, you can control encryption to the data on disk, and you can provide auditing capabilities, determine who's accessed the data and what access methodologies they used to get to the data. And then we're going to have a look at an example of utilizing a trigger to create a data warehouse. You may have a requirement to create data in a normalized fashion that's ready for the use of a third-party report writing tool like iReports, BB Jasper report tool, for example, and perhaps your data is not well structured for that kind of ad hoc user-generated reporting. Or perhaps you don't wish to have your production database impacted by very lengthy queries. In that case, you may wish to hive off the data into a data warehouse. And so we'll talk about the traditional approaches towards a data warehouse and some of the new functionality that can be employed with triggers. And then lastly, we'll look at the integration of new modules utilizing the AddonSoftware example. So let's talk about the Sarbanes-Oxley Compliancy. We can prevent or allow user access to a data file based on the user, the connection type, the particular table or file name, or the column or field within that table. So by relation to user, you could restrict access to particular fields. You're also able to implement on-the-fly data manipulation. The good classic example might be to encrypt, say, a credit card number or social security number on disk, but not have to make changes to application code. We could decide to normalize data. So right now, perhaps you have a header and a detail record being written into one data file. You could utilize triggers to normalize that data on the write. So using an instead of write trigger to write that data to separate data files. We could also do some validation. Perhaps right now your validation requires comparing to an existing table, an existing mkeyed file on your application, but perhaps in future you wish to interrogate a third-party database, and perhaps that's not even available on your local system. You may be wishing to do some validation via a web service, and you can do that validation by utilizing a trigger. And of course, lastly, we can log file access for the creation of an audit trail of when that data might have been accessed and by which user. The other use cases could be to back up or synchronize data, keep a third-party database in sync. And there we can take advantage of our JDBC connection pooling to make for very rapid use or reuse of a JDBC connection to a third-party database. We can also decide to save deleted records. Traditionally, older applications would have deleted a record and permanently deleted it from disk. We can intercept that remove statement and actually write away that deleted record to a deleted records database without having to make a single change to a single line of code within the application. Lastly, we may have a need to have notification when files are accessed or changed or when a threshold is reached. So, for example, should an outstanding balance be reached for a particular AR type, you can generate a flash email, text message, or a page to the user, to the person that you believe in your organization needs to be alerted to these changes. So very easy to implement that utilizing the trigger functionality. So let me hand over to Nick and we'll have a look at some examples of some of those Sarbanes-Oxley compliancy type trigger use cases.
One potential use case for triggers would be to limit access to the database based off of connection information, such as the user that's querying the database or perhaps even the connection methodology that they employ. As a case in point, it's possible to determine if the user attached to the database via an ODBC or a JDBC connection, and then block access to the data if that's the case. We're going to do just that in this example, except that instead of blocking all access from ODBC or JDBC sources, instead we're going to allow read access but block write access. So let's take a look. We'll start off with our customer file manipulation program, which is a handy utility that allows us to make changes such as write records and remove records and SQL updates and deletes, as well as reads with read records and SQL selects to our Chile company customer data file. Since we're testing SQL, the first thing that we'll want to do is make sure that we can read a record from the customer data file. So we'll click on Select, click the Execute Code button, and it was able to read a customer name. The next step is to attempt to do an SQL update. Click on the Execute Code button, and sure enough, it wrote out customer number 13. So now we've shown that we can both read records and write records. So what we'll want to do is put some triggers in place that will still allow those connections to do read records but block all write access to the database. So the next step is to run our trigger creation utility. I've pre-selected the type of trigger to create, which is the one that will disallow ODBC write access. And when I click on the Create Triggers button, it will iterate through all of the tables in the database and define the appropriate triggers. So now that we have the triggers in place, let's run our test once again. So back to the customer file manipulation program. I'll check the Select button and we'll ensure that we can still read a record from the customer data file. Yep, we've read customer number 70. Now let's see if we can do an SQL update. This time the update failed, which is just as we expected. After all, we put triggers in place to block SQL writes and removes to our database. In this case, you can see that the execution results window says that there was a problem updating the row. ODBC/JDBC connections are not allowed to make modifications to the database. And then in parentheses it says my custom trigger error. So let's take a quick look at the code and see how we accomplished that. I have the trigger loaded up in the Basis IDE here. And you can see there are just a few lines of code that take care of this for us. In the beginning of the program, we defined our trigger object. The next part of the code does all of the work. This part will abort the write operation if it's an ODBC or a JDBC connection. You can also choose to abort the operation based off of the user that was attempting to modify the file, if desired. It starts off on the if statement by checking the connection string and checking to see if it starts with the string ODBC. If so, then it knows that the person that is attempting to connect to the database is coming in through an ODBC or JDBC connection. In that case, it will define a custom error message, which we saw in our application program, and then use the BBJ throw verb to throw our custom error message along with your error number. And in our case, we're choosing error 18 because that's usually associated with the permissions error. So that's a quick example of how to use a trigger to prevent write access to a database based off of connection information such as the user that's connected to the database or the methodology that they've employed to make that connection. Another possible use case for triggers would be to have them retain all records that would normally be lost whenever someone removed a record from a database. For example, our application is written to allow users to permanently delete information from our database. If we ever want to get that information back, we would have to go to our most recent reliable backup. Triggers offer a simple solution to that problem. Just create a before delete trigger that will be responsible for archiving off the data record before it's removed from the database. Here's an example of that code. We get a BBJ trigger object, find out which record the user intends to delete, and then make a copy of that in another table called deleted customers. So let's see that in action. We'll bring up our customer file manipulation program as well as Enterprise Manager, which gives us a listing of everything that's in the customer table. So we'll start off in the customer file manipulation program, and this time we're going to remove a record. Click on the Execute Code button, and now it says we've removed customer number 6. So we'll go back to our customer table. There was a customer number 6, so when we execute this query once again, Now customer 6 is gone. So in other words, customer 6 has been permanently removed from the customer table. However, the trigger was responsible for moving that over to a new table called deleted customers. So for example, I can do a select star from deleted customers, and sure enough, there's our customer number 6. We can go through the exercise one more time, remove one more user. This time we've removed customer number 12. So when I do a select star from customer, customer number 12 is no longer in the list. And now when I select star from deleted customers, now we have both customer number 6 and customer number 12 retained in there. So that's a good way that you can use triggers to maintain information without losing it permanently. Another possible use case for triggers is to log file access. For example, it's possible to use triggers to create an audit trail for a data file. This next example shows how we've done that by defining triggers for a data file. The trigger captures information of interest, such as the timestamp, the data file that was accessed, the file operation type, the key or record that was accessed, the user accessing the record, and how the user connected to the data file in the first place. We'll start off by taking a look at our audit trail log viewer, which gives us a peek into the audit trail for the Chili Company customer data file. Right now, when I click on refresh, the grid is completely empty because no one's accessed the file yet. So the next step is to actually access the file through a couple of different methodologies. We'll start up the customer file manipulation program, and we'll read through the customer file two different ways. To start off with, we're going to do a file system read from BBJ. This uses your traditional read record. Click on execute code, and it's read customer number 4. So now when I go back to the audit log viewer and I do a refresh, you can see that we've got an entry in there. We've got the access time for the data file log, the file name that they accessed, our customer data file, the operation type, this was for an after read trigger, and you can see that the key matches, letting us know that the username achild connected via BBJ and read record number 4. So let's do another read operation. This time though, we're going to use an external SQL select. This select should come out looking a little bit different because we're not connecting via BBJ interpreter. Instead, we're connecting through an SQL select where we're defining the user as admin. So after clicking execute code, it reads customer number 17. And back in our viewer, if I do a refresh, you can see that we've got a new entry. We've got a new access time, same data file, same operation. However, this time, admin is the user that connected via ODBC or JDBC and read customer number 17. So that gives you an idea of how you can use triggers to log all access to your data files. Another great use case for triggers is to have them encrypt and decrypt sensitive data on the fly. For example, we can introduce triggers into a working application and have them be responsible for encrypting credit card information. Our application was originally written to read and write the customer's credit card numbers in plain text to a BBJ mkeyed file. But this can be a potential security risk, as the numbers will be visible to anyone with physical access to the data file. To solve this problem, we've created triggers to encrypt and decrypt the data to and from the disk, unbeknownst to the application. On the screen, we're taking a look at the inside of the Chili Company customer data file. Most of the information is stored in this data file as plain text. For example, we can see customer number 1, the name, Gregory Baldrake, the company, Bogus Stuff, even their address, 8508 Manitoba Street. However, we've encrypted the credit card information so that prying eyes will not be able to glean any important information from this data file. That's what all of this gibberish is actually. It's the credit card information that's been encrypted before it's been written to the disk. But all of that's been done by triggers. Let's take a look and see how they work. In Enterprise Manager, I can do a select star from customer. When I execute that, it'll give us a listing of all the customers in the data file, including their credit card information. However, in this case, we're looking at the credit card information as it is decrypted off of the disk. This is all done through triggers. If I click on the Triggers tab up top, switch over to my customer data file, and edit it, you can see that we've got some triggers defined to do the encryption and decryption for us. So what would happen if I turned off the triggers on this data file? Well, that means that the triggers would no longer fire and would no longer be responsible for encrypting and decrypting the credit card information on the fly. So let's turn them off temporarily and see what we get. We'll go back to our chili company, and we'll do our select star from customer once again. We get our customer list, although this time the credit card information comes back just like you saw it in the data file. It's encrypted and no one can make heads or tails of it until we turn on the triggers once more. It's a simple matter of turning the triggers on to the data file. We go back to our database. We'll select the information once again, and now you can read our credit card information. So that's a good example of how you can use triggers to encrypt and decrypt sensitive information in your data files without making radical changes to your applications.
Thanks very much, Nick. All right, let's have a look at data warehousing. We mentioned earlier that we have the option to produce a data warehouse solution utilizing triggers. Well, let's look at why that would be worthwhile. Our current solution might be a time-consuming bulk copy to a third-party database, perhaps run overnight or once a week. The database is non-relational as it currently stands, so we need to convert it into a relational database. The database is currently non-normalized nor indexed for efficient queries, so that's the reason that you would utilize the data warehouse solution, moving it across to the bulk copy. The newer trigger solution would be to create a replicated basis database utilizing our exclusive SQL table type, which is a relational, fully relational table type, normalized and indexed for your efficient queries. And then you utilize the trigger to copy only the modified records to the new database, those records that are deleted or those records that have been changed. So your benefits are more efficient. Obviously, a very small percentage of records are going to be required to be changed in the database, whereas your bulk copy copies 100% of the records, which you have no knowledge of which ones might have changed. It's dramatically faster, of course, than a bulk copy. So your data is available immediately. Your queries will perform optimally with the appropriate indexes on the data files, on the relational tables. Data is always current because we have the real-time updates, so more accurate, more cost-effective. There's no need to purchase the third-party database to enable your data warehousing. Let's have a look at that in action.
BBJ ships with several demos, including a few that deal specifically with data warehousing. The first demo that we're going to run, the Data Warehouse Creation Utility, makes a replica of the Chili Company database. The new copy of the database is called the Chili Company _ Data Warehouse, and it utilizes one of BBJ's more advanced file types, ESQL, for the back end. ESQL stands for Exclusive SQL, and as the name implies, these files can only be accessed via SQL and not by traditional means such as a read record. They do offer several advantages such as support for foreign keys, constraints, and transactions. The Data Warehouse Creation Utility creates an ESQL-based copy of any database on our system and dutifully creates every table and copies every record in the database. We've just finished running the program, and as you can see, it's gone through every single table in the Chili Company database and copied over every record into the data warehouse copy. So the next step in the process is to create triggers that will be in charge of keeping the data warehouse version of our database in sync with the live Chili Company database. The triggers ensure that all of the data modifications to the original database are applied in real time to the data warehouse version, ensuring that the two databases match one another at all times. So here's our trigger creation utility. I'll specify the type of trigger that I want to create and click on the button to create the triggers. The program will walk through every single table in our Chili Company database and create the appropriate triggers that will be responsible for syncing up the two databases. Now that that's done, it's time to put these triggers to the test. To put this to the test, we're going to run 2 copies of our data-bound grid table viewer. The one on the left will go to our Chili Company, and we'll tell it to go to the customer table, and we'll uncheck the read-only connection. So now our program on the left is accessing the original Chili Company database and taking a look at the customer table. The program on the right we're going to change to go to the data warehouse version of the Chili Company database. So we'll select that database from the drop-down and select the customer table from that one. And now on the right-hand side, we're looking at the corresponding table, but in the data warehouse version of the database. So it's time to make a change now in our original Chili Company and see if that change gets propagated automatically to our data warehouse version. To do that, I'll edit the first customer record in the customer table. I'll change his name from Gregory, for example, to Bob. Now let's take a look and see if that change made it through to our data warehouse version. All I have to do is click on the refresh button and it will gather the new information from the table. And as you can see, when we refresh the data, the customer's first name change went through just as we expected in our data warehouse. This gives you a quick overview of how you can use triggers to maintain 2 different databases and keep them in sync with one another to implement data warehousing in your organization.
The last topic I wanted to cover today was to talk about the integration of new modules. And here at Basis, we've utilized triggers to facilitate that integration of new add-on software modules. But this would apply to any of your own environments where you decided to create a replacement module perhaps to your existing module and you wanted to integrate that to your older module. What we did is we integrated a new general ledger and accounts payable modules with our old accounts receivable. As you can imagine, our business is somewhat unique. We sell licenses, we don't carry stock of goods. We have a mechanism whereby we can deliver that product across the internet. So a standardized AR system really doesn't meet our requirements. And so we've evolved with a very customized solution over the years, and to replace that with an off-the-shelf AR solution would be rather difficult. But that AR solution currently links into an older GL package. We wanted to utilize a new GL package, and this is how we did it. We used a trigger that when the old AR tried to write to the old GL transaction file, the trigger intercepted the write and redirected it to the new GL. So we used an instead of write. The AR would also look to the old GL master file for lookup of allocation codes, and it continues to do that. We just used a trigger to duplicate any changes to the new table and duplicate those to the old table. And we introduced 2 parameterized modes within the trigger code, so we could switch this off via parameter. We could run it in parallel where it would update both the old and the new tables, and we could also enable login to ensure that we were getting the results that we were expecting. But there were no code changes to the old modules. The old AR system is oblivious to the fact that we've replaced the old GL with a new GL. It just works. So very low risk and very high functionality. So this is just an example of the trigger code. It's a GLT-04. Those of you that have ever worked with the AddonSoftware product will be familiar with that. And we essentially just caught the write before the write and then replicated the output to the appropriate new file. So in summary, what have we covered today? We've looked at a discussion on what triggers are, what they can do. We've looked at some good use cases for those triggers that'll facilitate some easy upgrades to your application. We've looked at providing Sarbanes-Oxley compliancy in the area of auditing transactions, controlling access to the data, and providing encryption on disk. We've looked at a simple data warehouse type solution, giving you examples of how that might be implemented utilizing triggers. And we've looked at how we can integrate new modules into existing older modules, by utilizing triggers to redirect updates. So we could plug in, for example, the more modern add-on software accounting building block modules. So you could plug those into your own application solutions and merely make sure that you have a trigger in place to redirect output from your old update to the new update. Before I start answering your questions, let's have a quick look at the upcoming Java breaks. The next Java break will be reporting in Barista. We'll show you all the reporting mechanisms that we have with Barista, how we can easily move across legacy reports or create brand new, very stylized iReports and integrate them into Barista. And in between that is our dockout functionality, how we can generate faxes, emails, PDF file formats, etc. from within Barista. That'll be on May the 5th, same time, same place. So look forward to seeing you there. And of course, upcoming training that I think is specifically relevant to today's session is the Basis DBMS, SQL, SPROX, and triggers. That'll be on May the 6th, the day after our next Java break. That'll be a web-based session. So come and learn about the new functionality we've added with SQL, store procedures, and triggers. Look forward to seeing you there. Over to your questions.